Hi, welcome back. We have our next guest speaker, Uma.
Hello. My name is Uma. I'm the co-founder and CEO of Succinct, and today I'm going to be talking about how every rollup is going to be a zk rollup. So I think something that gets talked about a lot in the Ethereum community is the notion of zk rollups are the end game. And maybe a lot of people agree with that, but hopefully the point of this presentation is to convince you that not only are zk rollups are the end game, but that they're actually here today, right now, with what we're building at Succinct. So today, most of the rollups that are deployed in production are optimistic rollups. Think rollups like Arbitrum, Base, Optimism mainnet. And the reason that is the case is that when those rollup teams were working a few years ago to deploy rollup technology, zk was still hard. It was very difficult, it required a lot of cryptography, and so optimistic rollups were the fast go-to-market option. But optimistic rollups actually have a lot of hidden costs. The obvious one is the long time to finality, where you have to wait 7 days to withdraw your funds. And that's really bad because it locks up capital, it degrades user experience, and it makes interoperability between rollups really hard. Also, these optimistic rollups have very complicated contraptions for their interactive fault-proof game, which has this challenge period and interactive challenges that are economically incentivized. And in the end, the systems end up being very, very complex and actually hard to reason about. So as I was mentioning, why are most of the top rollups by TVL optimistic rollups today? That was because back a few years ago, launching a zk rollup was really hard. Developers needed to implement cryptography and custom zk circuits to make things like a zk EVM. And proof generation was really, really expensive. So it would make the end user experience bad because transactions would cost a lot because you had to generate a proof for them. And finally, optimistic rollup teams went to market early. They had a hard time switching to zk, even if those things were now different and zk proving costs have gone down a lot because there's a lot of sunk cost in their existing stack. At Succinct, we're building a zkVM called SP1, where you can just use zk by writing normal Rust code. So SP1 is kind of a breakthrough in the zk paradigm, where you no longer have to code custom circuits or do any complex cryptography. You can make a zk EVM by just writing normal Rust code, like taking things like ref or revm, and getting them to in SP1 and getting out zk proofs. So companies now can just make a zk EVM by using SP1, and then they can use the Succinct prover network to generate proofs very cheaply and cost effectively.
Lower the mic just a little because it's covering your face.
Oh, cool.
Okay, there you go.
And finally, now that zk is really easy and very cheap, existing rollup teams can just take their existing rollup stack, which is written in normal code, stick it in SP1, and get a fully working zk rollup end-to-end. So we actually built this out for the OP stack. It's our integration called OP Succinct, and I'll go more into this later in my talk about how it actually works and kind of who's using it. So let's dive a little more into the performance of zkVMs and how there's kind of this Moore's law where zk is getting cheaper and cheaper and faster every year. We launched our zkVM SP1 around 1 year ago, and back then we were able to prove around 60,000 cycles per second. And those are RISC-V cycles, which is the instruction set that we prove. Since then, over the past year, we've gone from being able to prove 60,000 instructions per second to 4.8 million to be exact, instructions per second. So that is a hugely dramatic increase in our throughput, which also translates to way cheaper proving and way faster proving. And we're also building this prover network, which is basically a hosted proving solution for SP1. So SP1 is a piece of open source software. You can use it, you can run it on your laptop and generate zk proofs. But in practice, to make things cheap and fast, you need to run zk proving on GPUs or other custom hardware to make it very efficient. And so our prover network is this solution where developers can send a program and an input via an API to request a proof. Provers and GPUs all across the world basically generate the proof and send it back to you and get paid. And it becomes this protocol where everyone can get zk for as cheap and fast as possible. And that's what we're building. So with SP1 and the Prover Network, I like to say that we're in a new era of ZK, which I like to call ZK 2.0, where now anyone can use ZK in a much more modular way. In ZK 1.0, which was kind of the old way of doing ZK, where you had ZK rollup teams like Scroll and zkSync and Polygon, each of those teams would have to build all parts of the stack. So they would have to build their own rollup implementation, their own sequencer, node software, block explorer, et cetera. And then they would also have to build their own proof system, and they'd have to build a bunch of complex cryptography and circuits for a zk EVM. And they'd also have to build their own prover and host all that infra themselves. In all, it was a huge lift, and that's why all these ZK rollup teams took a really long time to go to market and were many years behind the optimistic rollup teams. With ZK 2.0, what happens is now everyone can use SP1, our zkVM. They just write normal code, and then they can use our prover network so that they don't have to have their own proving infra. So you can just tap into ZK, but with the normal code, and then you can build whatever you want. You can build a ZK EVM, you can build a ZK SVM, you can build whatever VM you want, whatever state transition function you want. Really, whatever software you want to prove is finally provable. And this dramatically makes using ZK easier, the go-to-market timeline's way faster, and also expands the types of things that we can ZK prove. And so our hope is kind of in the ZK 2.0 era, ZK is finally easy, fast, cheap, and can get adopted everywhere in the stack, and will allow every rollup to be a ZK rollup. So hopefully I've convinced you at this point that, with SP1, our zkVM, and the Prover Network, ZK can finally live up to its potential. And now I'll talk a little more specifically about what we're doing to bring ZK to every rollup with OP Succinct, as I mentioned earlier. So OP Succinct takes the OP stack, which is a very popular rollup framework, and sticks it inside SP1 to get a full ZK rollup, which we call OP Succinct. And in particular, there's a lot of advantages. You have 1 hour fast finality. You can prove everything. And it's pretty fast and reliable with cheap costs. However, we also have another offering called OP Succinct Lite, which is perfect for rollups that are more cost sensitive. And this replaces the interactive fault-proof games that are used by a lot of current optimistic rollup teams and replaces it with a single-shot fault-proof, where instead of having this interactive back-and-forth dispute, in the case of a challenge, you can just verify a single ZK proof. And here, the kind of trade-off is that you get much cheaper costs because you aren't proving every single transaction. You're only proving something in the unhappy path where something goes wrong. But you still get slower finality than the full ZK option, so maybe around a day, because you have to still allow for time to generate the challenge proof and submit it. But you improve upon the 7-day finality that most optimistic systems have. So OP Succinct is kind of a good middle ground between full ZK and the interactive fault proofs. So in general, with OP Succinct Lite, I think one thing that's pretty interesting to note is that I believe it's a strict improvement beyond the interactive fault proofs we have today. Today's interactive fault proofs, like Optimism and Arbitrum are using in production, are very complex multi-round economic disputes. With a ZK fault proof, you can just resolve your dispute in a single step by verifying a proof. This means that not only are your finality windows shortened from 7 days to 1 day, it also means that your bond sizes that you have to put down for this economic game go from being hundreds of ETH to tens of ETH, which is much more efficient. And so you get lower bond sizes, faster finality, and just an overall much simpler code base, which is really awesome. So we think that ZK fraud proofs are future-proof and kind of the endgame direction of interactive fault-proof games. And then OP Succinct, which is kind of full ZK, where every transaction is ZK proving, gets you even better. You get really, really fast finality. So you can have finality in 1 hour, 1 day, maybe even tens of minutes. You get cheap, cost-effective proving, where the cost of proving per transaction ranges between 1/100th of a cent to 1/10th of a cent. So that's very, very affordable, especially compared to Ethereum DA costs. And then finally, because your state transition function's written in normal code, and our zkVM lets you use ZK with normal code, if you want to add a new precompile or you want to customize your rollup, that's no big deal. You can just do that. You can write the code, stick in SP1, and everything will still work. So we think with both OP Succinct and OP Succinct Lite, every single OP stack rollup kind of has a path to this ZK future. So if you're a large L2 with strict security and interop needs, or a DeFi chain that has a lot of high-value transactions where you don't care about 1/10 of a cent here or 1/100th of a cent there, OP Succinct's a perfect solution. You can become a fully ZKified chain. If you're a more cost-sensitive L2 with thin margins, like a gaming chain or something where there isn't a lot of financialized activity, then OP Succinct Lite with ZK fault proofs is a great solution for you, and in our opinion, a strict improvement to the interactive fault-proof games that we have today. And I have an image here of an electrical engine, which is dramatically simplified compared to the complex gas engine that I kind of showed earlier. To me, the gas engine represents interactive fault proofs. They're complicated, they're clunky, there's a lot of steps going on, it's hard to reason about. OP Succinct Lite makes ZK fault proofs very streamlined and very friendly, and we think that's the future that all rollup teams should take. And I guess there is becoming more and more broad agreement on the ZK rollup future, where every rollup is going to be a ZK rollup. And Vitalik says he was even thinking about that in 2021. And the main concern is still proving costs. But especially with that ZK Moore's Law chart that I showed you earlier in this presentation, hopefully you're convinced that proving costs are on an exponential trajectory to getting better and better. And actually, we even have a few OP Succinct chains running live today. And in practice, the cost per transaction is around 1/10 of a cent or 100th of a cent. So it's at the level of existing L2s already. And so I think the time is now for chains to start adopting either full ZK or at the very least ZK fault proofs to kind of go towards this future that we see for Ethereum rollups. And kind of as evidence of what I was saying of people already using this technology, we actually have a bunch of customers for both offerings that are using this today. So we recently announced that we're working with Mantle, which is a ZK, which is an L2 with a lot of TVL, around 2 billion in TVL, one of the largest L2s, and they want to convert their chain to be fully ZK with OP Succinct. And we have another chain called Fala that does TE AI agent experiments on their chain that's using OP Succinct in production right now. In addition to that, we have a bunch of other customers that are going to use OP Succinct Lite in the upcoming months as they think ZK fault proofs are a strict improvement on the security they have today. And there's a ton of infrastructure partners across RAS and AltDA that are also supporting both OP Succinct and OP Succinct Lite. So in sum, hopefully this presentation convinces you not only that a ZK is the end game, which is a common phrase heard throughout the ecosystem, but also that ZK is here right now. It's easy, it's cheap, it's fast with OP Succinct, and people are adopting it today, and we should be moving towards that future to have a better, more interoperable Ethereum. Thank you.
Thank you so much. It was a pleasure to listen to hear you speak. So.